You remember it, don't you? 9 names whispered in classrooms, lined up like children waiting for roll call beneath the sun. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, the smallest, the farthest, the loneliest one. It always came last, but somehow that made it special, didn't it? The little planet that refused to fade from memory even when distance swallowed it whole. And then one day the universe got smaller. In the late summer of 2006, astronomers from around the world gathered in Prague for the 26th General Assembly of the International Astronomical Union. The hall was bright, sterile, serious. Words were exchanged, definitions, categories, orbits, semantics, and in the middle of it all, one small word quietly disappeared from our maps: Pluto. In that moment, the solar system lost its 9th planet and humanity lost a piece of its childhood. The decision seemed rational. After all, science thrives on precision, but you could almost feel something break like a sigh traveling through every planetarium and classroom on Earth. Children asked why, teachers hesitated, and astronomers, those who had spent their lives watching the outer dark, sat in silence, because somehow, even if the math made sense, the heart of it didn't. Have you ever seen something erased, not because it was wrong, but because someone decided it no longer fit the definition? They said Pluto wasn't alone, that it was just one of many icy objects drifting in the Kuiper Belt, a ring of debris beyond Neptune filled with frozen remnants of the early solar system. They said a planet must clear its orbit, sweeping away other bodies with its gravity like a cosmic broom. Pluto, small and light, could never do that. It was demoted to dwarf planet, sharing its fate with others that had never been granted fame in the first place. Yet even as it fell, Pluto refused to vanish. In the same year it was stripped of its title, NASA had already sent a messenger racing toward it, a slender silvery probe named New Horizons. Launched in January 2006, it carried the dreams of a generation that refused to forget. It was the fastest spacecraft ever built, propelled by an Atlas V rocket with 5 solid boosters reaching speeds close to 58,000 kilometers per hour, fast enough to pass the moon in just 9 hours. You might think that sounds mechanical, but if you listen closely, there's something almost poetic about it. In the year humanity abandoned Pluto, humanity also reached out to touch it. 9 years later, that outstretched hand would arrive. But in 2006, when the vote was cast, most people didn't know any of this. They just saw a small world being pushed aside. They didn't see the data waiting to be written or the images that would one day make them cry. Maybe that's how science often feels progress built on heartbreak. Pluto was never large enough to rule its orbit, but it was bright enough to be noticed. Discovered in 1930 by Clyde Tombaugh, a young farm boy from Kansas who built his first telescope out of tractor parts and grinding wheels. Pluto was a dream found in flickering light. Night after night, he compared photographic plates, searching for a moving dot among thousands of frozen stars. On February 18th, he saw it, a tiny speck that had shifted slightly between 2 frames. He'd found something that moved against eternity. He'd found proof that discovery doesn't always belong to those with power. Sometimes it belongs to those who keep looking when others have stopped. When Pluto was named, it wasn't after a scientist or a myth of war or beauty, but after the god of the underworld, a place unseen, shadowed, mysterious. The suggestion came from an 11-year-old girl in Oxford, Venetia, Burney, who imagined the cold edge of space belonging to the god who ruled where sunlight ends. How fitting, isn't it, that a child named the most distant world, that a boy found it. and that adults decades later would decide it didn't count. Still, the universe has a way of keeping score. From NASA's archives, we know Pluto's orbit is unlike any other, stretched and tilted, sometimes bringing it closer to the Sun than Neptune, sometimes dragging it billions of kilometers farther. It takes 248 Earth years to complete one orbit. That means, since its discovery, Pluto hasn't even made it halfway around the Sun. Imagine that a world whose year lasts longer than all of modern human history. Maybe we just didn't wait long enough to understand it. You picture it now, drifting beyond Neptune's sunlight, weak and pale, less than 1,000th of what we feel on Earth. Its surface frozen at 229 degrees in nitrogen and methane, locked in ice so hard it behaves like rock. But still there's motion there. Winds that sweep across plains of frozen nitrogen, shadows that move, the faint outline of a beating heart waiting to be seen. When you think about it, Pluto didn't lose its place because it changed. We did. We redrew the boundaries. We needed order, categories, symmetry. 8 planets, clean, perfect, predictable. But the cosmos has never cared about our need for neatness. The universe is messy and beautiful and full of contradictions. It births stars from chaos and hides oceans beneath ice. Why should planets be any different? Maybe that's what drew scientists like Alan Stern, the principal investigator of New Horizons, to fight for Pluto's honor. He once said, "It's not that Pluto isn't a planet, it's that we decided to shrink the definition to fit our convenience." His team didn't just send a probe, they sent a rebellion, a whisper through the void saying, "You still matter." Sometimes late at night when data travels through NASA's Deep Space Network, faint radio signals crossing billions of kilometers, you can imagine those pulses as a heartbeat. Each one takes more than 4.5 hours to reach Earth. Each one says, "I'm still here." And isn't that what you'd want too, to still be heard, even after being forgotten? Maybe that's why the story of Pluto feels human. It's a world too small to clear its path too far to be easily seen, and yet too stubborn to disappear. When you think about it, every one of us has been there, standing at the edge of someone else's definition, waiting for a chance to prove we belong. So on that summer day in Prague, when the delegates raised their hands and stripped Pluto of its title, they might have thought they were tidying up the universe, but they were also teaching us something deeper, that belonging isn't always about size or power or category. Sometimes it's about persistence. If you close your eyes now, you can almost see it, a small dot against the endless dark, still orbiting, still shining, waiting for the moment when humanity will look again and say, "We were wrong." Because the universe never forgets. It only waits for us to catch up. You drift outward now past the blue orbit of Neptune, the last of the giant worlds. The sunlight fades until it's no brighter than a pale star, weak but steady. Around you, silence grows thick, the kind of silence that has weight. Out here, space is no longer a stage for planets and moons. It becomes something else, a cathedral of darkness, where one tiny world moves alone. This is Pluto's kingdom. It doesn't shine like Jupiter or burn like Mercury. It doesn't command an army of moons or wear a crown of rings. Instead, it glides in a crooked, tilted orbit, an exile circling the sun in slow defiance. It takes 248 Earth years to complete a single revolution. When you were born, Pluto was somewhere near the edge of its journey. When your great-grandchildren are old, it still won't be home yet. The path it follows isn't neat or obedient. While most planets orbit on a flat shared plane like beads on a string, Pluto's orbit, is tilted by 17 degrees, slicing above and below the solar system's disk. And that orbit isn't a perfect circle. It's a stretched oval, pulling Pluto much closer to the Sun for part of its journey, and then casting it back into the deep for decades. For about 20 years in the late 20th century, Pluto actually came closer to the Sun than Neptune. You might think that would cause chaos, two planets colliding in some cosmic accident. But nature has its choreography. The orbits of Pluto and Neptune are locked in a 3-2 resonance, meaning for every 3 orbits Neptune makes, Pluto completes exactly 2. They never meet. They dance around each other, always missing by design. Isn't that strange? That even in chaos, there is rhythm, that 2 worlds can avoid collision, not through luck, but through harmony. NASA once called Pluto the archetype of the Kuiper Belt. Out here beyond Neptune lies a vast region of frozen debris, remnants from the solar system's birth. The Kuiper Belt stretches billions of kilometers across, filled with icy fragments of methane, nitrogen, and rock raw material that never formed into planets. Pluto is the brightest of them all, a lonely monarch ruling a kingdom of shattered beginnings. But it's not the biggest. That title goes to Eris, discovered in 2005, slightly smaller in diameter, but more massive, a discovery that forced astronomers to re-examine what truly defines a planet. That's when the whispers began. Maybe there are hundreds like Pluto. Maybe the edge of the solar system isn't empty at all. You look around, and the idea becomes almost overwhelming. The dark is crowded. There are worlds with names few remember, Haumea, elongated and spinning like a cosmic football. Makemake, bright and red and barren. Beyond them, even stranger shapes drift in frozen quiet, half rock, half ice. It makes you wonder if every tiny object tells a piece of the solar system's story. How much history have we never read? Pluto is small, just 2,376 kilometers wide, barely 1/6 the diameter of Earth's moon. Yet its gravity is strong enough to hold onto an atmosphere, at least when it's near the Sun. Methane and nitrogen sublimate from its icy surface, rising into a fragile haze that can stretch hundreds of kilometers above the ground. As it drifts farther out again, that thin air freezes and falls back like snow, coating the landscape with layers of glittering frost. It breathes in and out with each orbit, a slow planetary heartbeat lasting centuries. Can you imagine a world that inhales once every 200 years? It feels alive in a way we didn't expect. Not with life as we know it, but with motion, with memory, with a pulse. The same sunlight that warms your skin on Earth travels 5.9 billion kilometers before it touches Pluto. By then, its warmth is reduced to almost nothing, and yet that faint light is enough to make nitrogen move enough to stir a wind enough to remind us that distance does not equal death. When NASA's New Horizons probe was still millions of kilometers away, its cameras caught sight of Pluto and its moon Charon circling each other like a pair of dancers. Charon is large, about half Pluto's size, and the two are locked in a gravitational embrace so perfect that each shows only one face to the other. On Pluto, the same side always faces Charon. On Charon, the same side always faces Pluto. They spin together around a shared point in space, a barycenter located just above Pluto's surface. To an observer far away, it looks almost like they orbit an invisible anchor, a binary world bound by balance rather than dominance. What would it be like to stand there, to look up at a sky where one moon never moves? Would it comfort you or haunt you? The more scientists studied this strange relationship, the more it felt like poetry disguised as physics. Some speculated that Charon was born from a colossal impact billions of years ago, when a proto-Pluto collided with another icy body. Instead of destruction, they became partners. The energy of that ancient crash may still warm Pluto's interior, keeping a hidden ocean liquid beneath the frozen crust. That's the paradox of Pluto. The farther you go from the sun, the warmer it becomes inside. Maybe that's true for us too. The colder the world, the deeper the fire it hides. As New Horizons moved closer, NASA's instruments began mapping Pluto's orbit with exquisite precision. The spacecraft used the sun's gravity and Jupiter's slingshot to speed up crossing 4.8 billion kilometers of space in just 9.5 years. Every trajectory, every course correction was planned decades in advance. And yet the moment the first images came through, two faint dots merging into a tiny sphere, all the equations in the world couldn't capture what people felt. That dot was real again. It was more than a category. It was a place. You might not realize this, but when NASA first aimed New Horizons toward Pluto, there was no guarantee the target would even exist by the time it arrived. The navigation team had to calculate without fresh images, trusting models and faith. When it finally approached in 2015, the probe was traveling over 14 kilometers per second, too fast to stop. No second chances. One pass, one window, one look. Humanity's only encounter with the most mysterious member of our solar family. The data began to arrive: light curves, particle counts, temperature readings, and then at last, photographs. A small world tinted gold and red with a pale heart shining across its midsection. The heart of a planet we had once abandoned. Even from billions of kilometers away, the images had emotion. That's not science, that's something else. Maybe recognition, maybe forgiveness. And somewhere in all of this you realize that Pluto has never been truly beyond. It's been circling all along, patient, faithful, invisible, waiting for us to look back. When NASA received the first clear images, Alan Stern said softly, "We are seeing a living world." A living world not because it breathes oxygen or grows forests, but because it changes. It has weather movement, geological youth. It defies stillness. The edge of the solar system is not the end, it's a mirror. When you look into it, you don't see exile. You see persistence. Perhaps you felt that before, standing at the border of something vast and cold, wondering if you still belong. If so, Pluto would understand you. And as New Horizons flies past, leaving only a whisper of radio waves and a trail of light, Pluto continues its endless orbit, gliding through the black with the patience of eternity. It doesn't ask for its title back. It doesn't need revenge or recognition. It just keeps moving. Maybe that's what greatness really is, not being at the center, but enduring at the edge. For almost a decade, the spacecraft sailed in silence. No eyes, no heartbeat, only the hum of radiation and the cold stretch of time. You can almost picture it, the New Horizons probe, no larger than a piano gliding through black space at more than 14 kilometers per second. The faint sunlight no brighter than a distant candle. It carried one mission: to meet the most misunderstood world in our solar system. After traveling nearly 4.8 billion kilometers, the probe began to wake from hibernation. Commands beamed from NASA's Deep Space Network took over 9 hours for a round trip, 4.5 to reach the probe, 4.5 to return. Each signal was a whisper across the void, a reminder that even distance cannot silence curiosity. And then for the first time in human history, Pluto came into focus. At first, it was just a few blurry pixels, two faint points of light, Pluto and its moon Charon. But with each day, those dots grew clearer, merging into shapes, patterns, landscapes. What had been an abstract idea for 85 years began to transform into a world with color, texture, and scars. Imagine being one of the scientists at NASA that week. You've spent half your life chasing a world most people had forgotten, and suddenly it's looking back at you. On July 14, 2015, New Horizons made its closest approach, flying just 12,472 kilometers above Pluto's surface. The entire encounter lasted a few hours. Decades of planning, 9 years of travel, all for a glimpse shorter than a sunrise. And yet those few hours changed everything we thought we knew. The first image that arrived stunned the world. Pluto wasn't just a cold rock of ice and shadow. It had color-rich gold, pale blue, deep crimson. And in the middle of that frozen desert, a shape caught everyone's eye, a vast, bright region, smooth and luminous, forming what looked unmistakably like a heart. They called it Sputnik Planitia, named after Earth's first satellite, a tribute to beginnings. The left side of the heart was rugged, mountainous, scarred by frozen nitrogen glaciers flowing from the highlands. The right side, wide, flat, smooth as glass, was an enormous plain of solid nitrogen ice stretching more than 1,000 kilometers across, about the size of Texas. Here's the mystery. This surface showed almost no impact craters. That means it's young, constantly reshaped, renewed. Somehow, in a world where sunlight is weak and temperatures plunge to 229 degrees Celsius, the surface is still alive. How could something so far away, so cold, still move? NASA scientists studying the data realized that even in the deep freeze, Pluto's interior was still releasing heat, not from sunlight, but from radioactive decay deep within its rocky core. That slow warmth rises through the icy crust, creating convection cells, slow, endless currents where ice melts, slightly rises, cools and sinks again, just like lava on Earth. The movement leaves behind a pattern of polygonal ridges across the plane, a cosmic fingerprint of a living world. You can see it in the high-resolution photographs, pale blocks of nitrogen ice with darker lines dividing them, like skin stretched over invisible breath. It is the slowest motion imaginable, yet it speaks of life not in the biological sense, but in the planetary one of change, renewal, persistence. And maybe that's what makes this image unforgettable. When the world saw Pluto's heart, it wasn't just geology. It was recognition. You've seen that shape before in sketches of love and Valentine cards and symbols of connection, and now there it was, carved into a world 5 billion kilometers away. How can a machine built from metal and code reveal something that feels so human? Isn't it strange how the universe keeps reminding us that we're part of it, even through a lump of frozen nitrogen orbiting in silence? Beneath that icy plain, NASA's data hinted at something even more astonishing: the possibility of a liquid ocean buried beneath hundreds of kilometers of frost. The way Pluto's gravity interacts with Charon suggests the world is not entirely rigid. That subtle flexing may keep its inner ocean from freezing solid. If that's true, Pluto could share something profound with moons like Europa and Enceladus, secret seas hidden in the dark, warmed by the faint echo of creation. So the planet we erased might still hold the thing we most search for: warmth, movement, the potential for life. But Pluto wasn't finished surprising us. The probe also captured towering mountains of water ice as high as 5 kilometers, with peaks gleaming like shards of glass. Unlike Earth's frozen nitrogen water ice, at these temperatures is so hard, it behaves like stone, the foundation of the planet itself. Around the heart, dark red plains stretch outward, stained by Tholin's complex organic compounds, created when ultraviolet sunlight and cosmic rays strike methane in Pluto's atmosphere. These tholins drift down like fine snow, painting the surface with a reddish hue. Even here at the edge of sunlight, chemistry keeps creating color. Do you ever wonder how something so far so forgotten can still paint itself in light? Scientists believe Pluto's thin atmosphere, composed mostly of nitrogen, with traces of methane, may rise hundreds of kilometers high, scattering sunlight into layers of blue haze. When New Horizons turned its camera back after passing the planet, it caught a final breathtaking image, the sun setting behind Pluto, its rim glowing with 20 layers of soft blue light. The color wasn't added, it's real. Blue, the same color as our sky. For a moment, everyone in the control room fell silent. That image didn't look like a scientific target, it looked like home. Perhaps that's the deepest lesson Pluto gives us. Even a world exiled from the category of planet can still reflect the same beauty we recognize in ourselves. You can almost feel it, that quiet message in the data, as if the universe were whispering, even in the coldest place, something still glows. When the final signal from New Horizons reached Earth, Alan Stern looked at the image of the heart and said softly, "This is what exploration is for, to remind us how little we know and how much we can still love." And you listening now might realize that in some way you're part of that journey too. Every question you've ever asked, every night you've looked up and wondered why, feeds the same hunger that launched that tiny probe across the dark. Maybe you've been like Pluto, small, distant, misunderstood, but the universe never stopped shining on you. It just took longer to arrive. The heart on Pluto isn't just frozen nitrogen. It's a mirror, one that reflects the persistence of life, curiosity, and love itself. And as New Horizons continues sailing deeper into the Kuiper Belt, leaving that glowing heart behind you, realize something extraordinary. Sometimes it takes a machine to teach us how human we still are. You can almost hear it if you're quiet enough, not a sound but a rhythm, a faint inhale, a long, patient exhale. That is Pluto's breath. For centuries, we thought this little world was silent, frozen, dead. But when New Horizons passed by, the spacecraft found something no one expected, a thin, trembling atmosphere wrapping the planet like a sigh. It's made mostly of nitrogen, with whispers of methane and carbon monoxide. Fragile, yes, but real, the ghost of weather on a world where the sun is just another star in the sky. When sunlight touches Pluto, something begins to stir. The faint heat, 1,000th of what reaches Earth, is enough to warm the surface, just slightly melting a fraction of nitrogen frost into gas. It lifts away, rising high above the plains, forming a shimmering layer of haze. The process is called sublimation, when a solid turns directly into vapor without becoming liquid. Here, it's the heartbeat of a world. You can imagine standing there, if you could stand in that gravity, if your lungs could bear the emptiness, looking up at a sky where sunlight diffuses into 20 layers of thin blue haze. Each layer distinct, suspended, like the notes of a cosmic chord. How can something so cold, so distant, create something so beautiful? It is not constant. Pluto's atmosphere breathes with its orbit. As the world draws nearer to the sun, it exhales, gases flow upward, wrapping it in a soft blue veil. As it drifts away again, that air freezes and falls back, coating the ground in frost. Every 248 years, a single planetary lung fills and empties. You can almost feel it under your skin, can't you? That slow, impossible rhythm, proof that even in darkness, something still moves. The surface pressure of Pluto's atmosphere is barely 100,000th of Earth's, yet that's enough to scatter sunlight into color. When New Horizons turned its camera back after the flyby, it caught Pluto in silhouette, the sun glowing behind it like a halo. No one expected the color that emerged. Blue. Not gray, not white blue. The image arrived at NASA's control room in quiet waves of data. It took over 4 hours just to cross the distance. When the picture finally appeared, people gasped. Some cried. Alan Stern whispered, "Blue skies on Pluto." Why blue? Because even here, the laws of light remain loyal. Tiny particles haze made of tholins and frozen nitrogen scatter the sun's rays in the same way molecules of oxygen and nitrogen scatter them on Earth. It's a different recipe, but the same color, the same message, the universe reusing its most comforting shade in the unlikeliest place. You can almost imagine it, that distant twilight over a world we once erased from our maps. A horizon glowing with blue, the faint outline of mountains below and above it all, the eternal moon Charon hanging still, as if watching over a sleeping friend. What does it mean that a place so far from warmth still paints itself in the color of home? Scientists studying Pluto's atmosphere realize something astonishing. It isn't a fragile mist frozen in time, it's active. The gas flows across the planet, carrying heat and particles shaping weather. Some regions near the equator collect more sunlight, creating gentle winds that move haze and frost from one hemisphere to another. In that thin breath, Pluto writes its own seasons. And every time it nears the sun for a few brief decades, the world wakes up. Its air thickens, perhaps reaching 1/4 of the pressure found on Mars. Enough for nitrogen snow to fall gently, for fog to drift through valleys, for glaciers to creep forward grain by grain. What happens when the sun fades again? When the planet turns back toward its 200-year winter, the atmosphere begins to collapse. It doesn't vanish, it just sleeps. The gases freeze, returning to the plains of Sputnik Planitia as layers of frost. And there they wait for another century for the sun's light to return. Pluto's breath is slow, but it's also faithful. There's something profoundly human about that, isn't there? The idea that life, or something like it, doesn't have to happen quickly to matter. That even a world moving at the edge of light can still keep time with the universe. Sometimes the line between science and poetry disappears. You realize that the data we collect, numbers, graphs, wavelengths, are just translations of feeling. Every rise in atmospheric density, every spectral trace of nitrogen is a heartbeat written in mathematics. Out there, 5.9 billion kilometers from the sun, a machine built by our hands recorded that heartbeat. New Horizons drifted past Pluto and looked back, and in that backlight, the haze glowed blue, the heart gleamed white, and suddenly everything we'd dismissed as dead became alive again. For the first time, humanity saw the weather of an exiled world, thin fogs hanging in the valleys, frost glittering along the ridges, shadows moving across the heart. It wasn't chaos, it was delicate balance, an orchestra of ice and light. Do you ever think about how many things breathe without lungs? Oceans, forests, even planets. Maybe Pluto reminds us that breathing isn't just for the living. It's what connects everything that endures. Expansion, contraction, light, dark, warmth, cold. The cycle never ends, it just slows until only patience can feel it. NASA's data showed another wonder at dawn and dusk. The haze of Pluto thickens, glowing brighter at the edges. It's the same phenomenon that gives Earth its crimson sunsets. But here the color is reversed. The sunset turns blue, deep and melancholic, as if the planet exhaled light itself. Imagine standing there during that moment. The sun, a golden spark barely above the horizon. the sky layered in translucent blue, frost glinting beneath your feet. You breathe in knowing the air is unbreathable, and yet in your mind, you share the same motion. And perhaps that's the truest connection between us and this frozen wanderer. We both turn sunlight into memory. Pluto's atmosphere may one day disappear entirely. Maybe 1,000,000 years from now, the last trace of nitrogen will settle into permanent frost, and the sky will go dark. But even then, it will have existed. It will have glowed and moved, and reminded us that the definition of life is not confined to warmth or heartbeat or biology. It is presence. It is rhythm. It is motion where none should exist. As New Horizons sailed onward, leaving Pluto's blue haze behind the signals, its scent grew weaker but never stopped. Each one a small echo across time, the sound of humanity breathing through its machines, the same way Pluto breathes through its ice. Somewhere billions of kilometers away, that world still exhales. The sun's light still touches its plains. The frost still shimmers. And though no one is there to see it, it doesn't matter. The act of existing is enough. Maybe that's the real lesson Pluto teaches you, that beauty doesn't need to be seen to be real, that warmth doesn't need to be felt to exist, that even at the edge of everything, the universe is still capable of breathing. And if a world that cold can keep its rhythm for billions of years, then so can you. Mountains aren't supposed to exist here. Not in this cold, not in this silence, not at the edge of sunlight. And yet, when New Horizons sent back its first close-up images of Pluto, humanity stared in disbelief. There they were, giant peaks, 5 kilometers tall, rising from the ice like frozen cathedrals. Sharp ridges cut through the plains, shadows stretched for miles. The world that was supposed to be still and dead was sculpted alive with motion. These mountains are made not of rock, but water ice, so cold, so dense it behaves like stone. At 229 Cu, even nitrogen turns to rock and methane to glass. But water frozen solid becomes the backbone of continents. In that cold, it's stronger than granite. You can almost see it now, sunlight weak and golden, falling across crystalline cliffs, Charon hovering above the horizon, motionless in an eternal stare. When those images arrived at NASA, there was a long silence in the control room, because what they were seeing shouldn't exist. What force in a world this small and far away could have built mountains like these? That question became a heartbeat through the halls of the mission lab. On Pluto, gravity is weak, barely 6% of Earth's, and there's no tectonic activity as we know it. The planet should be geologically dead, yet the data told another story. The surface of those mountains was young, nearly unscarred by impact craters. They weren't relics of the past. They were signs of something still happening. One mountain stood out among the rest, a vast, gently sloping giant named Right Mons, nearly 150 kilometers wide. Its summit was hollowed by a deep depression, not from an asteroid impact, but from collapse, a caldera, the mark of a volcano. Except this volcano did not breathe fire. It breathed ice. Cryovolcanism. That's the word NASA used cold volcanoes. Instead of lava, they release a slushy mix of water, ammonia, and methane bubbling slowly from within. It's strange, isn't it, how even the coldest worlds can still find a way to erupt. Next to Right Mons stands Picard Mons, taller and rougher, another frozen monument rising from a plain of nitrogen ice. Together they look like twin sentinels, guardians of Pluto's defiance. The ground around them is fractured, curved, uplifted. It speaks of heat, the kind that rises from deep within, reshaping a surface thought to be long dead. But where could that heat come from? The sun is too far, its warmth reduced to a faint glimmer, and Pluto is far too small to trap much of its original energy. NASA scientists offered two possibilities. One is radioactive decay, the slow release of energy from elements trapped in the rocky core since the solar system's birth. The other is tidal heating, caused by the gravitational pull of Pluto's large moon Charon, tugging rhythmically at the crust, bending and flexing it, keeping its interior soft. Maybe it's both. Maybe the universe never relies on just one miracle. When New Horizons mapped the area around Right Mons, it found something even more remarkable: almost no impact craters at all, only one. That single fact changed everything, because if the surface were ancient, it would be pocked with scars. The absence of them means that something geology heat motion has been erasing the past. So, what if Pluto isn't dead? What if even now it's quietly rebuilding itself beneath that frozen crust? The thought feels impossible, yet so did mountains made of ice. Infrared readings revealed subtle color differences on the peaks: fresh frost here, older frost there. Some slopes reflected more sunlight than others, suggesting recent resurfacing, perhaps caused by slow eruptions or venting gas. These events could happen once every few million years. For us, that's eternity. For Pluto, it's rhythm. How long can something this far from warmth keep moving? To scientists, these mountains are a sign that Pluto still has an internal pulse, faint but steady. To everyone else, they're a metaphor. The idea that even in the most frozen corner of existence, pressure still creates beauty. The closer you look, the more impossible details you find. Around the base of the cryovolcanoes are vast plains of frozen nitrogen smoothed by slow glacial flow. At their edges, you can see cracks like veins stretching for hundreds of kilometers perhaps, faults, perhaps breathing lines where the planet releases stress. NASA's models suggest there could be a liquid ocean buried deep beneath all that ice. A hidden sea warmed by the same radioactive decay that fuels those ancient mountains. If true Pluto joins a small family of worlds, Europa Enceladus Titan, that keep oceans alive in the dark, could something be stirring in that darkness? Not life perhaps, but chemistry, the first whisper of it. Molecules moving, reacting, combining. If even the smallest planet can nurture that possibility, what does it say about the rest of the cosmos? It makes you wonder how many other dead worlds are simply waiting to be understood. In one of the probe's final close-up frames, sunlight catches the rim of Right Mons. The peak gleams like glass. Below, shadows pool in the caldera. It looks quiet, but quiet isn't the same as stillness. Beneath that silence, the planet is still dreaming of motion. Maybe that's what Pluto has been trying to show us all along, that creation never really ends, that the universe isn't a finished story, but a sentence still being written, even in the margins of darkness. Because if a world this cold can still lift mountains, then what else might rise when no one's watching? Beneath Pluto's frozen skin, there may be something moving, something ancient, patient, and almost impossible in ocean. You wouldn't think it could exist. From so far away, the sun is nothing more than a pale ember, its light too weak to melt even a memory of ice. Pluto's surface sits at 229 degrees C, and the crust above that hidden ocean could be over 150 kilometers thick. By every law of thermodynamics, water here should be locked silent solid for eternity. And yet NASA's data tells a different story. When New Horizons passed by, the probe's instruments recorded subtle distortions, tiny irregularities in Pluto's gravitational field, gentle bulges in its shape. The pattern didn't fit a world of stone and ice. It suggested something flexible beneath the crust, something capable of shifting, expanding, flowing. And there's only one thing that behaves like that: liquid. Could Pluto, the forgotten, the exiled, still hold a liquid sea beneath its heart of ice? The thought sounds almost romantic, doesn't it? But it's science, precise, mathematical, and profound. The data pointed to a subsurface ocean trapped between a rocky core and an icy shell, kept alive by internal heat and the insulating power of ammonia acting as an anti-freeze. It wouldn't be an ocean like ours with waves and light and life. It would be dark, viscous, heavy with salts, but it would be liquid. And that means motion, that means energy, that means memory. Imagine it, a vast sea sealed in darkness. Since the birth of the solar system, its pressure so immense that water behaves more like syrup than waves. Above it lies a world of ice, below it a bed of ancient rock releasing just enough radioactive warmth to keep the ocean from freezing. It's the perfect paradox, a living heart beating beneath a dead exterior. Do you ever wonder how many things in the universe look frozen yet hide warmth inside? When scientists studied the bright plains of Sputnik Planitia, they realized it might not just be a surface feature. The heart-shaped basin could be a window into Pluto's interior, a clue to that hidden ocean below. The ice there seems thicker than expected, pulling on the planet's gravity, creating a mass excess where there should be a depression. Only a layer of dense, salty water beneath could explain the readings. So the heart of Pluto might literally be floating on an ancient sea. Think about that for a moment. Every photograph you've seen of Pluto's white heart, that shining symbol of resilience, could be resting on liquid water, invisible yet alive. If true Pluto joins a growing family of ocean worlds, Europa, Enceladus, Titan, and maybe even Triton, places where water refuses to die, where darkness doesn't mean lifelessness, it suggests a new truth about the universe, that warmth doesn't always come from sunlight. Sometimes it comes from within, and maybe that's true for us too. NASA's scientists modeled what might be happening below the surface. As radioactive isotopes in Pluto's rocky core decay uranium, thorium, potassium, they release a faint constant heat. Over billions of years, it's not much, but with nowhere to escape, it accumulates. The bottom of the ice crust begins to soften. Convection starts a slow, endless churning, mixing warm and cold ice and liquid. A cryogeological cycle begins. The ocean keeps melting the crust above while refreezing behind it. The movement drives the glaciers, uplifts mountains, and refreshes the surface. Every bright plain and frozen peak is an echo of the sea below. How strange a world that transforms, not because of fire, but because of patience. When New Horizons left Pluto, it looked back one last time. The images showed sunlight spilling across the rim of the planet, scattering into blue haze, illuminating the outlines of valleys and ridges. Beneath that calm glow hidden under kilometers of ice, the ocean remained unseen, yet still shaping everything above. It's easy to imagine that ocean as a kind of consciousness, not a mind, but a memory. A record of every change Pluto has ever endured, written in layers of liquid and frost. If you could descend through the crust, through the nitrogen plains and frozen mountains, you would eventually hear it, the faint crackle of ice shifting, the deep hum of pressure, the whisper of movement, the sound of persistence. What would it feel like to stand above such an ocean, knowing it's been flowing longer than life on Earth? That question haunted scientists for years, because if liquid water can survive on Pluto in a place where sunlight is almost gone, then the conditions for habitability stretch far beyond what we once believed. Life as we define it needs three things: liquid water, energy, and chemistry. Pluto has all three. Could that mean something once stirred in the dark? Not organisms, perhaps, but precursors, chemical seeds drifting in an underground sea. We may never know. The probe is gone, and it will take centuries before another mission reaches that far. But the possibility remains glimmering at the edge of imagination. Sometimes science gives us more questions than answers, but maybe that's the point. Maybe wonder itself is the fourth ingredient for life. From orbit, Pluto's surface looks quiet, pale, smooth, unbroken. But those plains are deceptive. Beneath them, pressure builds, heat flows, the crust expands. Over geological time, that slow breathing lifts the surface, reshapes the mountains, refreshes the frost. When NASA compared the oldest and youngest terrains, they realized the planet is still evolving. The ocean, though unseen, remembers. It remembers the impact that may have formed Charon, a cataclysmic collision billions of years ago that could have melted the entire planet for a brief burning moment. When the fragment settled, Pluto froze again, but not completely. Deep inside, the liquid survived. And it's been there ever since, guarding the planet's warmth like a secret candle. If the ocean ever freezes entirely, Pluto will shrink slightly, the surface will crack, the heart will scar. But as far as we can tell, that hasn't happened yet. The heart is still intact. Maybe that's what draws us to it, this defiance of logic, this quiet refusal to go dark. Because in the end, Pluto isn't a story about exile. It's a story about endurance, about how even the smallest world can carry an ocean inside it, unseen, unheard, but still shaping everything above. If you listen long enough, you can almost hear it, a slow pulse beneath the ice, an echo older than history. And maybe that sound isn't just Pluto's. Maybe it's the sound of every human heart that ever wondered what else might be out there and refused to stop looking. At the edge of the sun's light, Pluto glows blue. Not white, not gray, blue. When New Horizons turned its camera back after passing the planet, the scientists weren't expecting much. Just one last look before the spacecraft disappeared into the Kuiper Belt. But what they saw stopped everyone in silence. The rim of Pluto, the world that was supposed to be nothing more than ice and shadow, was wrapped in a halo of radiant cobalt light. For the first time, humanity saw the sunset on Pluto. How can a world so distant from warmth, so cold that air itself freezes, paint its sky the color of home? NASA's data explained the physics, of course. Light scattering. Tiny particles suspended in the atmosphere, tholins, complex organic compounds formed when sunlight and cosmic rays break apart methane and nitrogen molecules. These fragments recombine, forming long carbon chains that drift upward, suspended high above the surface. There they catch sunlight and scatter the shorter, bluer wavelengths toward the eye of the observer. But somehow no equation can make that moment less miraculous. Imagine you're standing there on the rim of Sputnik Planitia, the vast heart-shaped plain. The sun is barely a spark above the horizon, 2,500 times dimmer than on Earth. Around you, the sky deepens from silver to indigo. Above, the thin atmosphere shimmers in 20 layers of haze stacked like veils. Each layer glows with faint blue light. Would you feel alone or seen? As the sun sinks lower, the haze brightens for a moment, refracting its last warmth before the light fades completely. The air is thin, almost absent. The pressure here is less than 100,000th of Earth's, and yet it's enough to scatter color, to create a twilight that feels impossibly gentle. That's the paradox of Pluto. Everything about it says no. No heat, no air, no motion. and yet it keeps whispering, yes. When the image of Pluto's blue haze first arrived at NASA's mission control, there was no applause, only quiet awe. Scientists stared at the screen, some with tears, others with open mouths. Alan Stern, who led the mission, simply said, That's Earth's sky color." It's hard not to feel something at those words, because that blue doesn't belong there. It doesn't belong to the edge of the solar system. And yet, there it is, as if the universe itself had decided to repeat its favorite color one more time. Do you think that's coincidence, or is it memory? On Earth, twilight is the hour of reflection, the moment when the world exhales and shadows stretch long. On Pluto, twilight is eternal. Every sunset lingers for hours as light refracts through haze so thin it might as well be breath. In those moments, the planet looks alive. NASA's instruments detected that the haze isn't uniform. It shifts and changes with time, forming delicate waves and ripples. Some scientists think these structures might be gravity waves, like those that ripple through Earth's own atmosphere when winds flow over mountains. If true, that means even Pluto's sky is dynamic. It moves, it changes, it dances. And isn't that beautiful that even in a place where nothing should move, the sky still dances? Beneath that sky lies a world of contrasts. The highlands, rugged, dark, ancient, absorb light like soot. The lowlands, bright, fresh, youthful, reflect it like glass. The boundary between them glows softly in twilight, painted in gradients of amber, rose, and blue. The air thins further as you climb higher until it's nothing but silence. Yet the color remains faint but faithful. Pluto's twilight doesn't vanish suddenly like ours. It lingers, a slow fade, like the dimming of a candle in an endless room. The light bends refracted by the planet's thin atmosphere, casting a soft rim around its horizon. From orbit, that rim looks like a glowing ring, an ethereal aura suspended in darkness. In those final moments before night, the world becomes translucent. The ice, the haze, even the shadows, they all begin to glow. What would it feel like to watch a sunset there, to see the last breath of sunlight scatter through nitrogen haze and know that no one has ever seen this before? Maybe that's the essence of exploration. Not discovery for fame, but for wonder. NASA's team studied the haze composition closely. They found two main layers of particles, a lower one about 30 kilometers thick, and an upper one extending nearly 200 kilometers into space. The lower haze scatters light directly, creating the deep blue color. The upper haze reflects sunlight back into space, making Pluto shimmer when seen from afar. The particles themselves are incredibly small, less than 1/10 of a micron, but together they transform the planet into something luminous. So even here, in a realm where sunlight is weak and distant, light finds a way to matter. And maybe that's the quiet message this world is trying to tell us, that you don't need to shine brightly to be seen. You just need to catch the light that reaches you, no matter how faint. As night settles, the haze cools, and the nitrogen vapor begins to freeze again, falling gently to the surface like blue snow. It's a slow, delicate process, each flake a tiny crystal of frozen air. Over time, these cycles of sublimation and frost shape the landscape, carving valleys, filling craters, thickening glaciers. Pluto breathes not in seconds or minutes, but in centuries. There's patience in that, the kind of patience we've almost forgotten. Somewhere in the distance, Charon hangs motionless, tinted red by tholins drifting from Pluto's atmosphere. The two worlds face each other forever, locked in mutual orbit, each showing the other the same face. Two companions in silence, sharing the same pale light. What do you think it means that even in the coldest places, something always finds another to orbit? Maybe that's why we look to the stars, not for answers, but for reflections, for reminders that even isolation can contain connection. When the image of Pluto's blue haze first appeared online, millions of people shared it. Not because it was scientific, because it was beautiful. For a brief moment, humanity looked at something 5.9 billion kilometers away and felt familiar. That's the power of light. It crosses impossible distances, refracts through invisible air, and finds your eyes. It tells you you belong to this universe too. And so Pluto, the outcast, the demoted, the forgotten, gave us one of the most human things imaginable, a sunset that reminded us of home. Somewhere the New Horizons probe is still traveling deeper into the dark, its signals growing fainter. But those images, those few frames of blue twilight remain as proof that beauty exists, even in the loneliest corners of the cosmos. If the sky can turn blue on Pluto, what else is possible? There is a world in the dark that has never seen sunrise, and yet it is never alone. When New Horizons looked closer at Pluto, it saw something orbiting so close, so perfectly synchronized, that the two might as well be holding hands. That companion is Charon, Pluto's largest moon, though moon hardly seems fair. It is nearly half Pluto's size, so massive that the two do not revolve like planet and satellite. They spin around a common center of gravity, suspended in the empty space between them, a place where no solid ground exists. From afar, they look like two dancers moving in slow motion, forever locked in one another's gaze. Every 6.4 Earth days, they complete a turn. Always together, always showing each other the same face. Imagine that standing on Pluto's near side, you would see Charon frozen in the same spot of the sky, never rising, never setting. A gray giant hanging over the horizon, its craters washed in faint blue light reflected from below. On the far side, the sky would be empty. You would never see it. Entire hemispheres live without ever knowing that companion exists. Do you think that's sad or sacred? Astronomers say Pluto and Charon are tidally locked, the gravitational embrace that keeps their rotation and revolution perfectly matched. But you might feel there's something more, a kind of cosmic trust. Neither world pulls too hard nor drifts away. They orbit balance itself. When Charon was first discovered in 1978 by James Christie, the data made little sense. The images of Pluto wobbled, shifting slightly back and forth every few days. Only later did scientists realize that what they were seeing was the pull of a companion large enough to tug the whole planet. Christie named it after the mythic ferrymen who carried souls across the river of the dead. Perhaps fitting after all, Pluto was already the god of the underworld. Together, they formed a myth reborn in ice. From NASA's data, Charon measures about 1,212 kilometers across, while Pluto spans about 2,376. Their shared center of gravity lies outside Pluto's surface, a feature unique among all planet-moon pairs in the solar system. Some scientists say that makes them a binary world rather than a planet and its satellite. Two equal halves of one story. Their relationship is written in the terrain itself. On Pluto's hemisphere that always faces Charon lies Sputnik, Planitia, the smooth, heart-shaped basin we've seen before. Directly opposite, on Charon's near side, there is a deep scar, a canyon system called Serenity Chasma, wide enough to stretch from New York to Los Angeles twice over. Perhaps they formed together as internal stresses mirrored one another, two worlds reshaping themselves in response to gravity's quiet tug. Can you imagine that connection an invisible thread between two frozen hearts, each bearing the other's mark. Charon's surface tells another tale. Unlike Pluto's kaleidoscope of colors, Charon wears muted tones of gray and red. The reddish hue near its north pole, known as Mordor macula, comes from Pluto's own atmosphere. As Pluto exhales tholins into space, some drift outward and fall upon Charon, tinting its pole in rust-colored dust. In a way, it's Pluto's breath made visible, a gift of color across 20,000 kilometers of emptiness. Every time Pluto's gases escape and freeze upon its companion, it's as though the smaller world is painting its own reflection onto the larger one. What a strange intimacy, a planet that colors its moon, a moon that shapes its planet's tides. And yet nothing moves fast here. Everything happens in geologic whispers. A sunrise takes 6 Earth days. A shadow takes hours to cross a plain. Even the exchange of dust and gas between them drifts like slow snowfall. In that silence, light behaves differently too. On Charon, you would see the sun, barely brighter than a distant star, but Pluto would hang enormous, above a faint turquoise orb glowing against black space. Its heart-shaped plane would shine so brightly that you could read by its reflected light. And yes, your own shadow would stretch blue across the ice. Pluto, for its part, sees Charon as constant, forever above the horizon, glowing like a loyal moon. Sometimes when Charon passes directly between Pluto and the sun, it casts a vast eclipse, a circular pool of darkness sliding over the icy plains. Temperatures dip even lower. For hours, the surface cools enough for vapor to freeze out of the sky. But when the eclipse passes, the light returns, and Pluto exhales again. It's strange to think that such stillness could create such rhythm. NASA's instruments revealed that Charon, like Pluto, might have once held an internal ocean. Its surface, fractures some stretching over 1,600 kilometers, suggests the crust expanded long ago, as if water inside froze and swelled, cracking the outer shell. That means once upon a time, Charon was warm enough to hold liquid water heated by radioactive elements in its rocky core. So here they are, 2 icy worlds, each harboring a secret memory of warmth. Doesn't that sound familiar somehow? 2 beings shaped by cold, but remembering heat. When New Horizons flew past in 2015, its cameras captured this binary system in perfect alignment. You can almost feel the gravity between them, not just physical, but emotional, as if the probe had stumbled upon a love story written in orbital mechanics. There's beauty in their symmetry. They orbit each other face to face, forever in conversation, but never in collision. That's not chaos, that's choreography. From Pluto's far side, the sky is empty, yet gravity itself whispers the presence of its twin. Even when unseen, Charon defines Pluto's balance. Without its partner, Pluto's spin would wobble wildly. Its seasons, its atmosphere, its climate, all would unravel. In a way, Charon is the reason Pluto can be Pluto at all. And maybe that's what partnership really means, stability in the dark. When the New Horizons team released Charon's close-ups, people expected a quiet, featureless world. What they saw instead were canyons, cliffs, smooth plains, even hints of cryovolcanic activity. One crater Organa shows deposits of ammonia-rich ice, possibly expelled from below. It's a reminder that even here at the edge of the sun's reach, the story is not over. The core may still whisper warmth. In those images, Charon looked ancient but not dead. The lines and ridges across its surface seemed to hum with patience, like wrinkles earned over time. If you could stand there on its equator, you'd see Pluto fixed above, glowing softly. The ice around your boots would glitter in blue reflections. The horizon would curve gently, smaller than Earth's moon. yet wide enough to make you feel alone. But above you, that turquoise light would never fade. Would you still feel small if the same world watched you every hour of every day? Astronomers sometimes call Pluto and Charon the loneliest couple in the solar system. But I don't think loneliness is the right word. They are the proof of connection without noise, a relationship defined not by distance, but by the constancy of presence. In an age when even planets are reclassified, renamed, and debated out of existence, Pluto and Charon remind us that meaning is not given, it's held. Two worlds orbiting an empty point, holding on to each other against infinity. Maybe that's what we all do in our own way. You expect volcanoes to burn. You expect fire-molten rivers and the sound of worlds reshaping themselves. But here on Pluto, the story flips the laws of nature. The volcanoes breathe not fire, but ice. When New Horizons approached the heart of this tiny world, it found two vast structures rising from the plains. Each was hundreds of kilometers wide, taller than Mount Everest, yet shaped not by heat from the sun, but by warmth from below. Their names, Wright Mons and Picard Mons. They look nothing like the volcanoes of Earth. No red glow, no smoke. Instead, their flanks are carved with soft ridges of ice-frozen flows that once moved like slush. The summits are hollowed vast and irregular, as if the mountain had erupted and then frozen mid-breath. It's strange, isn't it, to imagine a world so cold it burns with frost. Scientists call them cryovolcanoes, volcanoes of cold. Instead of lava, they spew water, methane, ammonia liquids that can exist only when temperatures fall far below what we call freezing. And here on Pluto, where the sun's warmth is just a pale echo, those icy mixtures can erupt, flow, and refreeze like slow lightning. How can such a thing even exist so far from the sun? The answer lies in heat that refuses to die. When Pluto formed 4.5 billion years ago, the collisions that built it filled its core with radioactive elements, uranium, thorium, potassium, the slow embers of cosmic creation. Even now, those atoms continue to decay, releasing faint warmth through rock and water. That heat seeps upward, softening the crust from below. And when pressure builds, it finds a way out. So, Wright Mons is not a mountain of destruction, it's a mountain of persistence. It is the planet exhaling, releasing the stored warmth of eons. If you could stand near its base, you'd see valleys carved by frozen floods, ridges formed by ice that once flowed like honey. The air around you would be still thinner than any vacuum chamber on Earth. Yet beneath your feet, the world would hum faintly, a slow, deep pulse, almost like breathing. What if planets too have their own kind of memory, not in thought, but in motion? NASA's measurements showed something startling. Wright Mons has only one visible crater despite being enormous. That means it's young geologically speaking. On Pluto, young can mean less than 1 billion years old, which to the universe is barely a sigh. That means the planet's interior may still be active now. Think about that, a world 6 billion kilometers away smaller than our moon still alive inside. The flow marks tell the story. Broad, overlapping lobes of ice spread out from the base like frozen rivers pouring from ancient vents. The slopes are steep, rising nearly 5 kilometers high, yet smooth as if the mountain had melted and refrozen. And the material isn't ordinary ice, it's water ice hardened by methane and ammonia. Those chemicals act like antifreeze, lowering the melting point enough for the mixture to flow even in Pluto's extreme cold. Under the right pressure, water behaves like rock, and here rock behaves like water. You can almost feel the poetry in that inversion. When sunlight hits those slopes, The ice glows faintly, a kind of inner silver-blue radiance. The shadows fall deep and sharp. The cratered plains nearby look ancient, but Right Mons looks alive. It is as if the planet had drawn one long, cold breath and then exhaled light. Do you ever wonder if even lifeless things can yearn to move? Pluto's smaller volcano, Picard Mons, sits farther south, equally massive but gentler in form. It has broad, shallow flanks and a collapsed summit, perhaps the remains of a chamber once filled with molten ice. Around it, the terrain ripples with faint ridges, frozen echoes of eruptions long past. Scientists suspect that both Wright and Picard may be connected to the same ancient plumbing system, a network of fractures linking the surface to the subsurface ocean. If that's true, then somewhere beneath those mountains, liquid water still exists today. In the dim light, the boundary between solid and liquid blurs. You can almost imagine translucent currents flowing just beneath the crust, slow as centuries. A hidden ocean, restless in the dark, pressing upward until it finds release. And when it does, it erupts, not with violence, but with grace, a fountain of frozen light that solidifies in the sky. NASA's instruments detected ammonia near the mountain bases, clear chemical fingerprints of cryovolcanism. Ammonia can't survive long on Pluto's surface. Cosmic radiation breaks it apart within millions of years. So if it's visible now, it must be new. That means something below is still stirring. That realization changed everything. Pluto isn't a frozen relic. It's an active world, one that might still evolve in silence. It reminds you, doesn't it, that life, or at least motion, doesn't require sunlight, just persistence. Somewhere beneath Right Mons, heat still seeps upward through rock and water. It may take thousands of years for that energy to reach the surface, but it never stops. The planet's slow heart keeps beating. What does it say about the universe that even at its edge, creation never truly ends? When the team at Johns Hopkins first saw the volcanoes, they didn't believe it. One researcher reportedly whispered, "It's impossible." Another simply said, "Then Pluto refuses to be dead." And maybe that's the lesson. Everything about Pluto, its tilted orbit, its icy plains, its blue haze, its double world with Charon, should have been chaos. And yet it holds together with improbable grace. Its volcanoes, sculpted by cold, erupt in defiance of expectation. They are proof that warmth can hide in unlikely places, that energy can survive long after its source should have faded. If you look closely, the terrain around Right Mons almost resembles coral, intricate branching, organic. Some scientists wondered if liquid flow could sculpt such delicate patterns. Others called it coincidence. But isn't that the nature of discovery, to find beauty before certainty? The cryovolcanoes are not erupting now, not as far as we can tell, but the evidence suggests they have many times across billions of years. Each eruption reshaped the plains, burying old craters and painting new scars. Then, the planet froze again, like a heartbeat, pausing before the next pulse. Perhaps even now, far beneath the surface, pressure builds once more, and maybe in another 1,000 years, Pluto will breathe again. Can you imagine that moment? The silence breaking, a surge of icy vapor bursting into the thin blue sky, scattering crystals into sunlight. For a few hours, the horizon would glow with drifting silver dust, the planet exhaling another secret into the dark. And no one would see it. No witness, no applause. Just the quiet continuation of a world that refuses to stop moving. That's the part that stays with you. Because in a way, isn't that what survival looks like? Not noise, but endurance. When New Horizons sent back its final images of Right Mons, they were blurry, incomplete. The probe was already leaving, speeding away into deeper space. But even in those blurred frames, you could feel the scale, the depth, the impossible beauty. A mountain of ice glinting under a distant sun, casting a shadow that stretched for hundreds of kilometers. For a moment, the universe seemed to whisper, "Even here, fire lives." There are places where light becomes air, and air becomes memory. On Pluto, that boundary is visible. When New Horizons looked back after its flyby, its camera caught something the team never expected. Layers upon layers of mist, each glowing faintly blue, stretching hundreds of kilometers above the surface. 20 layers stacked like the ribs of a ghost. The sunlight that reached them was weak, 1,000 times dimmer than daylight on Earth. And yet somehow those tiny particles scattered it with elegance. The haze was not just decoration. It was story, the visible breath of a planet still in motion. You can imagine standing there on the rim of Sputnik Planitia, again watching the faint light bend through the air. The sun sits low, a coin in an endless dusk. Between you and the stars drifts an atmosphere made not of comfort, but of courage. Nitrogen, methane, and trace hydrocarbons suspended at the edge of freezing. How can such fragility create such beauty? Each particle in that haze begins as a molecule lifted from the surface. Sunlight and cosmic rays strike Pluto's thin air, breaking apart methane and nitrogen, letting their fragments dance and merge into complex chains. Tholins, the organic dust that gives Pluto its reds and browns. But before they settle, they rise floating high enough to scatter blue light back towards space. They are born of radiation and ice, yet they look like hope. Every few hours, Pluto's faint winds push those hazes around. Some layers drift downward, thickening into fog that pools in valleys before freezing again at night. Others linger higher, like invisible rivers flowing over an invisible world. Scientists noticed that the haze brightness changes with altitude, not randomly but rhythmically, as if responding to unseen waves moving through the atmosphere. Perhaps gravity waves like those that ripple through Earth's skies when air moves over mountains. Even here at the edge of the sun's reach, the sky has music. Isn't that astonishing that silence can have rhythm? The probe's instruments measured how sunlight scattered as it passed through those layers, revealing their composition. The particles were tiny, no wider than 1/10 of a micron, yet abundant enough to make the horizon glow. Their density falls so quickly that each layer seems to float on nothing like lace hung between worlds. When the sun sets, the haze catches its last light, refracting it into an aura of cobalt and silver that circles the planet like a halo. You might call it a crown if you believed in such poetry. NASA calls it Rayleigh, scattering the same process that turns Earth's sky blue. But names are just doors. What matters is that two worlds, separated by billions of kilometers, share the same color when touched by light. Do you ever wonder if the universe repeats itself or if it remembers? In the lower atmosphere, those tholins fall as invisible snow drifting across the plains in slow motion. When they land, they tint the ice beneath them a deep reddish hue. Over time, these pigments gather into regions like Cthulhu Macula, the great dark streak along Pluto's equator. From orbit, it looks like a scar, but really it's the memory of light transformed by radiation beauty forged from decay. That contrast blue sky above red land below gives Pluto its haunting duality, light and shadow, warmth and cold, death and renewal. Somewhere beneath that atmosphere, you can still sense the faint pressure of the ocean we met before pushing upward. Heat from below, light from above, two forces that never meet, yet shape each other constantly. It's a quiet dialogue of physics and patience. At night, The haze dims but doesn't disappear. It glows faintly in starlight, almost phosphorescent. The probe detected subtle ultraviolet emission signs that solar particles still excite the molecules even in darkness. The atmosphere lives in layers of light we can't see, whispering in wavelengths beyond human eyes. If you closed yours, could you hear it? The soft hiss of nitrogen crystallizing, the gentle rain of methane dust falling back home. Some scientists think Pluto's atmosphere may collapse completely when it moves farther from the sun, freezing onto the surface like a ghost turning solid. Then centuries later, as its orbit brings it closer again, the frost will sublimate, rising once more as haze, a heartbeat measured not in seconds, but in centuries. That's what the haze truly is, Pluto's slow breathing. When you think about it, even planets exhale. The New Horizons images show faint rays extending into space, hazy beams like the fingers of dawn reaching upward. They aren't symmetrical. Some are brighter, some diffuse, as if the air itself remembers turbulence from long ago. In those uneven lines you can read a kind of story, a record of every time the planet warmed, cooled, froze, and breathed again. It's delicate, impermanent, and yet it endures. Back on Earth, scientists recreated Pluto's atmosphere in laboratory chambers. They exposed methane and nitrogen to ultraviolet light, watched the resulting chemistry unfold. Within hours, the walls of the chamber were coated in reddish tholin dust, the same pigments falling on Pluto now. When they dissolved that dust in water, it produced amino acids, the seeds of life's chemistry. Is it possible, then, that even at the edge of sunlight, the ingredients of life are still being written? The thought lingers like haze itself, intangible but persistent. You can picture it, tiny particles drifting through blue light, freezing, falling, thawing, rising again. A cycle of transformation so slow and silent that it becomes invisible unless seen from far away. That's the paradox of distance. Only when you stand far enough can you see the whole breadth. The haze gives Pluto its softness, the way fog gives memory to a landscape. Without it, the planet would be harsh and black. But through those layers, even the coldest world becomes gentle. Somewhere beyond the horizon, Charon hovers, a dark sphere reflecting the blue glow. Together, they orbit that empty center of gravity, their shadows blending. From the spacecraft's perspective, the light scattering through Pluto's haze looked almost like two overlapping ghosts. Maybe that's fitting. Two worlds once broken, still circling the same invisible point. That's the strange grace of Pluto's haze. It hides nothing but reveals everything. It is both shroud and mirror, veil and confession. Through it we see not only a planet, but an echo of our own fragility. When New Horizons sent those final frames back to Earth, scientists spent hours adjusting contrast, aligning filters, removing noise. But when they finally saw the blue haze in full clarity, the room fell quiet. No one spoke. One engineer whispered, "It looks alive." And maybe that's all they needed to say. Because life doesn't have to mean movement or biology. Sometimes it means persistence, the refusal to stop transforming even in the dark. The ghosts in the haze are not haunting Pluto. They are its breath, its memory, its promise. So if you ever look up at a night sky and feel small, think of that distant world exhaling light at the edge of the sun's reach. Think of the way color can bloom from coldness, how even silence can shimmer. And ask yourself, if Pluto can glow blue in the dark, what else might be waiting to shine? Half of Pluto glows like a dream. The other half sleeps in shadow. When New Horizons turned its camera toward the planet's night side, it found an expanse so vast and dark, it seemed to drink light itself, a continent-sized stain, stretching almost halfway around the equator. Scientists named it Cthulhu Macula, though some prefer its quieter name, the Dark Plains. From a distance, it looks like a scar deep red against the surrounding white. Up close, it's not uniform at all, streaked with hills, valleys, and frozen dunes tinted from copper to blood black. The surface here absorbs nearly every photon that touches it. Temperatures plunge even lower than the already lethal average, 240 degrees. Why is one side of Pluto bright as frost, while the other wears the color of dried fire? The answer, as always on Pluto, lies between light and time. Each molecule in that crimson crust began high in the atmosphere, born from sunlight itself. Ultraviolet radiation strikes methane and nitrogen, tearing them apart, restitching their atoms into long carbon chains, tholins. These organic compounds drift downward like ash and settle slowly over the centuries, coating the plains in pigment. Imagine its sunlight turning to dust, dust turning to color. You might kneel there, scoop a handful of that powder. It would feel soft as soot, yet older than continents. Under your glove, it would whisper nothing, because even sound freezes here. Isn't it strange that light can paint darkness? At the western edge of Cthulhu Macula, the terrain rises into broken ridges. NASA's maps show that these ridges align roughly east to west, shaped by slow winds dragging tholin snow before it settles. Even here, where the air is thinner than vacuum movement, never fully stops. Pluto's faint winds carve miniature dunes just centimeters high. When sunlight glances across them, their shadows ripple like frozen waves. The color itself changes with depth. Near the surface, the dust is dark and fine. A few millimeters below it brightens to rust red. Deeper still, where ice begins to mingle, the tone turns purple-brown. That gradient tells a story layer upon layer of cosmic weathering, centuries of radiation sculpting the same particles that once danced in air. Sometimes I wonder if you could read those layers like pages, what history would they tell? Cthulhu Macula stretches almost 3,000 kilometers from end to end. Along its rim lie craters so ancient they predate most of Pluto's surface. The oldest among them, about 250 kilometers wide, is filled with darker material than its walls, evidence that the scar keeps deepening itself as new tholins settle each orbit. But darkness here isn't absence, it's accumulation. The particles that fall do more than color the ice, they change it. When methane frost mixes with tholins, it traps heat differently. It sublimates slower, creating feedback that keeps the region darker and colder. The brighter hemispheres reflect sunlight, but this one holds it, amplifying its own stillness. Over millions of years, that thermal imbalance may even shift Pluto's rotation slightly, the planet turning ever so subtly to balance its weight of color. A scar powerful enough to tilt a world. What would it feel like to stand there under a sky of blue haze surrounded by red land that swallows every echo? Would you feel fear or reverence? There's beauty in the contradiction. Above you, light scattered by molecules barely clinging to existence. Below you, darkness made from the very light that created it. NASA's spectrometer found faint traces of complex hydrocarbons in these planes, acetylene, ethylene, ethane, simple ingredients that, under warmth and pressure, could weave into amino acids. It doesn't mean life not yet, but it means potential, the chemistry of imagination. Even here, in a desert of frozen air, the recipe is half written. Do you ever think the universe hides its most creative work where no one's looking? Toward the center of Cthulhu Macula, the terrain smooths out into rolling plains. Some scientists think this region once held a sea of liquid nitrogen that later froze. The pattern of cracks and troughs resembles dried riverbeds. If true, it means that at some distant epoch, warmth reached even this far enough for ice to flow like syrup. When it cooled again, the surface wrinkled as if the planet sighed and solidified mid-breath. A frozen sigh, that's what these plains feel like. From orbit, their edges blur into the brighter heart of Sputnik Planitia. The two regions meet like opposites in conversation, one bright young and dynamic, the other old quiet and red. Scientists believe material from the bright side may drift eastward over time, dusting the darker plains with frost that briefly lightens them until radiation darkens them again. A slow pendulum of color across centuries. Even the coldest world changes its face. Sometimes when you stare at the global map, Cthulhu Macula looks almost alive, a dark shape curling around the equator like a sleeping creature. Its eye, a large crater filled with black Tholen snow, seems to watch the light half of Pluto turn and fade. The resemblance to a mythic monster isn't accidental. Scientists named it after Lovecraft's cosmic horror, precisely because it feels ancient, unknowable, half-dreamed. But perhaps the real terror lies not in monsters, but in scale. Every grain of that red dust took decades to fall, every layer centuries to form. The entire scar is time made visible. What does it mean that a planet can wear its history on its skin? In a way, Cthulhu Macula is Pluto's memory, the record of every photon that ever touched it and didn't escape. The brightness on the opposite hemisphere may come and go, erased by glaciers and renewed by sunlight, but the dark plains persist. They are the parts that remember. NASA's ultraviolet data showed something unexpected during Pluto's night. This region glows faintly, not in blue like the haze, but in infrared. Heat from within still seeps outward, invisible to eyes, but not to instruments. Beneath kilometers of crimson dust may lie a thin layer of volatile ices, nitrogen and carbon monoxide, sublimating ever so slightly, feeding the air that forms the haze above. Even scars can breathe. When you think of it that way, the name Cthulhu feels less monstrous, more reverent, a reminder that darkness isn't death, it's transformation. Look again at the images, the blue edge of atmosphere hugging a red surface below, like fire and water intertwined. Two opposites existing in balance. That harmony feels deliberate, though we know it's coincidence, the universe's favorite illusion. Still, I can't help but ask, how many coincidences must we witness before they start to feel like design? In the years since New Horizons, Pluto's orbit has carried it deeper into the Kuiper Belt. Its atmosphere has likely begun to collapse, freezing onto the ground. If we could see it now, the haze might be thinner, the plains slightly brighter, where frost has returned. Yet the scar would remain patient beneath the ice, waiting for sunlight to awaken it again, because nothing on Pluto ever truly disappears. It only changes tempo. That's what makes the dark plains so haunting. They remind you that time doesn't erase, it writes in deeper shades. So the next time you look at an image of Pluto, half bright, half red, remember that you are seeing two eras of one world, the present glowing with motion, the past resting quietly beside it. One shows how light behaves, the other shows how it lingers. And maybe that's what all worlds and all people do, carry their brightness and their scars side by side. Somewhere in the middle of Pluto's endless silence, rivers still move, not with the rush of water, not with the sound of rain, but with patience, with centuries. If you were to look closely at the bright expanse called Sputnik Planitia, you would see patterns that look like cracks on an old window, or maybe the skin of some sleeping giant. But they're not cracks. They're flow lines, marks left by glaciers of solid nitrogen and methane moving slowly, steadily across the plains. It's strange to imagine, isn't it, a river that never makes a sound, a current that never melts? From New Horizons images, scientists saw it clearly. The surface of Sputnik Planitia isn't still. Huge cells, each 30 to 50 kilometers wide, rise and fall in slow convection. Warmth from below makes the ice expand and rise. Cold from above forces it down again. The result is motion, a frozen heartbeat reshaping the land over millions of years. It's a glacier ocean, solid and alive. You can almost feel it standing there in the blue twilight, watching the ground itself breathe beneath your feet. The plains look flat from afar, but from above they swirl like cream in coffee frozen movement, captured mid-thought. What keeps it moving when everything else around it is asleep? Beneath the nitrogen ice lies Pluto's hidden heat, faint, ancient, but still enough to stir the cold. Radioactive decay inside its rocky core, a whisper of warmth left from formation, drives the slow churn of solid gases above. That's why the surface here is so smooth, so young. Craters vanish because the ice below them rises to heal the wound. Even on a dead world, there's regeneration. At the edges of Sputnik Planitia, the terrain changes. Ridges form like frozen waves where the glacier meets higher ground. Methane and nitrogen creep up the foothills of surrounding mountains, carving valleys as they move. To the eye, it looks like liquid, glossy, sculpted, flowing. But in reality, it's rock-hard ice crawling over centuries under its own weight. On Earth, glaciers move meters per year. On Pluto, they may take centuries to shift even a few meters. But still, they move. And in that motion, there's meaning. NASA scientists traced the lines of those frozen rivers toward the center of the plain and discovered deep depression sinkholes where convection cells pull material downward. That's how the glacier circulates. Surface ice flows inward, melts slightly under pressure, then resurfaces at the edges as it freezes again. It's the same logic that governs Earth's atmosphere, just slowed 1,000-fold. Pluto too has weather. It simply happens in geological time. Do you ever think that maybe everything in the universe breathes just on different scales of patience? Even the colors here tell a story. The ice of Sputnik Planitia shines almost white because nitrogen reflects light brilliantly. But where methane mixes in, you see faint tints of peach and blue. These are the subtle fingerprints of chemistry, sunlight, and cosmic rays painting the glacier's surface molecule by molecule. In some areas, darker streaks run like veins where tholins have been carried down from the atmosphere and frozen into the flow. When sunlight hits them, the landscape looks like a sheet of marble, pale gold veins running through icy stone. Imagine the quiet. A river made of air flowing without sound, sculpted by warmth that no one can feel. The borders of Sputnik Planitia are mountains tall, jagged, mysterious. They rise up to 3,000 meters high, made not of rock, but of water ice, hard as granite in Pluto's cold. Some of these peaks cast shadows that stretch for dozens of kilometers across the plain. You can picture it, the sun low and far away, throwing long fingers of darkness across a glowing field of frost. On the slopes, small flows of methane ice creep downward, feeding the main glacier below. Each stream is so slow that if you stood there and watched for an hour, you'd see nothing. But if you came back 1,000 years later, you'd find the ground completely changed. That's the kind of time Pluto speaks. Sometimes movement doesn't need to be fast to be powerful. It just needs to endure. NASA's thermal data shows that some sections of the plain are warmer by a few degrees, suggesting heat leaking from below. That small difference, just 5 or 10 Kelvin, is enough to keep the nitrogen soft and convecting. You could say Pluto still dreams of the warmth it once had. Toward the southern edge, the glaciers meet the red terrain of Cthulhu Makula, the great dark scar we visited before. There, the white rivers fade into rusty dust, and the boundary blurs between light and shadow. Over millions of years, the red tholins drift north, dusting the bright ice while frozen nitrogen creeps south, whitening the scar's rim. It's a slow exchange, like two worlds breathing into each other. Isn't that what relationships are even between planets? Constant exchange, constant change, even when it looks like stillness. When New Horizons captured those first close-ups, one scientist whispered, "It looks like it's flowing." They weren't wrong. The ice flows follow gravity, moving toward the basin's lowest points. In some regions, they've even formed pits hundreds of meters deep, carved by sublimation, the process where solid turns straight to gas under sunlight. It's the opposite of melting, yet it leaves similar scars. The sun is so faint here that it would take 5 hours for its light to reach Pluto, but even that is enough to shape the surface. Over millions of years, sunlight gently lifts nitrogen molecules off the ice, and the winds weak but constant carry them elsewhere. The result, new frost elsewhere, bare ground, where it once gleamed. The planet remakes itself grain by grain. At the center of Sputnik Planitia lies a low basin, possibly an ancient impact crater. Scientists believe the impact created a depression that filled with nitrogen ice, and because ice is dense, it shifted Pluto's entire center of mass. That's why this glacier faces the same side toward Charon, always the two bodies locked in perfect resonance. It's like fate written in gravity. You could call Sputnik Planitia Pluto's heart, and you wouldn't be wrong. The bright lobe of the heart-shaped feature we see from space is this very plain, alive, moving radiant. It's both scar and renewal. It's where Pluto breathes. And maybe that's why people love it so much. Because even at the farthest edge of the sun's reach, even in the loneliest cold, there is still motion, still transformation, still the faint rhythm of life. Do you ever wonder if you stood there in that blue half-light, could you hear it? Not a sound, but something beneath it, the slow groan of a world that refuses to stop changing. New Horizons scientists often describe Pluto as active in its own quiet way. They mean that it defies expectation. It's too small, too cold, too far, and yet it moves. It's a reminder that stillness can be deceptive. That even when nothing seems to happen, forces are always at work beneath the surface. And maybe that's true for us too. The rivers of Pluto aren't really rivers. They are lessons in patience, showing that movement can happen even in silence and that warmth can persist even when surrounded by cold. Somewhere under that ice, maybe the last remnants of Pluto's heat still whisper upward. Somewhere above, light still scatters through blue haze. And in between them, the frozen plains rise and fall like breath. Everything changes, even the things that look eternal. So the next time you look at Pluto's distant heart, remember, it isn't frozen because it's dead. It's frozen because it's alive in slow motion. Beneath the frost, beneath the frozen rivers and red scars, Pluto hides something extraordinary, something alive but silent. Deep under its icy crust, there is an ocean, not of water as we know it, but of something ancient, a sea that remembers the beginning of the solar system. For decades, scientists assumed Pluto was too small, too distant, too cold for anything to move beneath its surface. But the data from New Horizons changed everything. The probe's measurements showed that the surface of Sputnik Planitia sits slightly lower than expected, as if the crust there had sagged under a hidden weight. That weight, NASA scientists now believe, is liquid water. Imagine that a secret ocean beneath a world colder than liquid nitrogen. How could it possibly stay liquid in such darkness? The answer lies in pressure, salt, and time. Beneath hundreds of kilometers of rock-hard ice, the water is kept warm by radioactive decay from Pluto's rocky core. Small amounts of heat trapped for billions of years seep outward, not enough to melt the surface, but enough to keep the lower layers from freezing solid. Add to that the intense pressure of the ice above, and the water below becomes dense, syrupy, and stable. It is the same kind of ocean believed to exist beneath Europa and Enceladus worlds that also hide their hearts beneath ice. But Pluto's ocean is older than Mars' rivers, older even than Earth's first rain. You can almost imagine it, a vast black sea sealed off for eons, still moving gently under a crust of crystal. No sunlight, no sound, just warmth and the slow pulse of planetary time. If you could stand on Pluto and look down with impossible sight, you'd see layer after layer surface frost of nitrogen and methane beneath it, the solid water ice crust, and far below the dark ocean pressing upward. That ocean may be 100 kilometers deep, and its bottom, the rocky core, may be hot enough to create chemical reactions like the ones that once sparked life on Earth. Could that really be true? Could there be chemistry or even something like life hidden there untouched since the dawn of time? Scientists can't say for sure, but the clues are compelling. When New Horizons measured Pluto's shape, it found the planet slightly stretched along one axis, a sign that liquid inside exerts pressure outward. The bright heart of Sputnik Planitia, that enormous plain of nitrogen ice, seems to sit directly above the thinnest point in the crust. This may not be coincidence. The weight of the ice there could have cracked the surface long ago, letting heat escape and the ocean expand upward, creating a massive basin. It's possible that Sputnik Planitia exists because of the ocean, not despite it. Think about that the feature that defines Pluto's beauty, its bright shining heart, may actually be the planet's wound, the place where its inner ocean first touched the sky. Some scientists even think that when the impact that formed Sputnik Planitia happened billions of years ago, it exposed the liquid beneath, freezing it into nitrogen glaciers that still flow today. The ocean below never vanished, it simply hid, pressing against the ice, whispering warmth upward. If you could listen, really listen, maybe you'd hear the faint groan of pressure, the slow movement of water pushing on a world that refuses to die. How strange that what we call frozen might still contain motion, and what we call dead might still breathe. NASA models suggest that the ocean is salty, rich in ammonia and other antifreeze chemicals. Those compounds lower the freezing point, allowing the liquid to stay fluid, even at 230 degrees. Over time, convection currents may stir it, carrying minerals from the rocky core upward, perhaps even feeding slow chemical reactions. And that's where imagination begins to stretch. Because if chemical energy exists, there heat minerals, water, then all the fundamental ingredients for life are present. Not life as we know it, but maybe life as it was, primitive, microscopic, quiet. Would you be surprised if something waited there? Something that never needed sunlight, only patience. We've learned from Europa and Enceladus that life can hide beneath ice, feeding on energy from rock and radiation. Could Pluto, the outcast of the solar system, be keeping that same secret deeper, older, lonelier? The thought makes your heart slow down. It's humbling to realize that the universe doesn't waste anything. Even the smallest world banished from the list of planets might still carry an ocean, and where there is an ocean, there is always a question. You can almost see it, the surface above scarred and frozen. Beneath it, a vast darkness glowing faintly red, stirred by warmth from the core. Water molecules swirling in slow circles, colliding gently, waiting for something that might never come. That patience, That's what makes Pluto sacred. New Horizons couldn't see the ocean directly, of course. It could only read the signs, the gravitational hints, the subtle bulges, the way light bounced from certain regions. But even without direct proof, the evidence tells a story. Pluto is not a block of ice. It is layered, living, and restless. Its outer world is winter, but its inner world remembers spring. Some researchers believe that cracks on Pluto's surface, visible as long fissures near its equator, could be the result of the ocean slowly expanding as it freezes. When water turns to ice, it expands, pushing outward and splitting the crust. The same kind of tectonic scars appear on other oceanic moons, like Enceladus and Titan. It's as if Pluto's surface is recording its ocean's heartbeat, one fracture at a time. Do you ever wonder if planets, like people, sometimes try to tell us what they feel? Not with words, but with the marks they leave behind. Maybe that's what the cracks are, sentences written in ice. If the ocean truly exists, it may have been there for 4 billion years since the planet's birth. It would mean Pluto has held on to its warmth longer than expected, defying logic, defying cold, defying isolation. It would mean that even out here, where the sun is only a pale star, something has continued to move, to change, to hope. And maybe that's why Pluto captivates us. It isn't just the beauty or the mystery, it's the resilience. The reminder that warmth can survive anywhere if it's deep enough. In the end, it doesn't matter if Pluto's ocean holds life or not. The fact that it holds possibility is miracle enough. Because in science, possibility is the first heartbeat of discovery. So picture it, one last time. Beneath the red plains and blue haze, beneath mountains of ice and rivers of methane, an unseen ocean rocks gently in the dark. It never breaks the surface. It never shouts. But it is there, waiting. And maybe one day, when another mission ventures farther past the edge of light into the silence of the Kuiper Belt, it will listen. It will send sound waves deep into Pluto's crust and hear echoes coming back from something fluid, something moving. And when that happens, we will realize the universe never gave up on Pluto. It was simply waiting for us to listen more carefully. The last time New Horizons looked back, Pluto was already shrinking into a distant pearl of light. The signal that carried those final images took over 4.5 hours just to reach Earth. By the time we saw them, the probe was already gone past Pluto, past its moon, Charon, sailing toward the deep unknown. But that's how every goodbye begins in space, not with silence, but with delay. When you watch the last photograph, you see something almost impossible, a glowing blue halo around a dark world. That halo is Pluto's atmosphere, sunlight scattering through tiny haze particles. The probe was already 200,000 kilometers away when it captured it, and yet the image feels close enough to touch. It looks fragile. It looks alive. How could something so small, so forgotten, still glow like that? Maybe because Pluto doesn't reflect light, it remembers it. After the encounter in July 2015, New Horizons began to turn its instruments backward, taking one final set of data as it left. What it found in those last moments was both beautiful and haunting. Pluto's haze extended hundreds of kilometers into space, much higher than expected. The sunlight filtered through it revealed at least 20 distinct layers each, a record of how the planet breathes. Even as it drifts through cold and darkness, Pluto continues to let go of molecules from its surface, nitrogen, methane, carbon monoxide, which rise, freeze, and fall again, like the slow exhale of a sleeping world. You might ask, if the air is that thin, why does it even exist? Because even nothingness tries to hold on to something. Behind Pluto, the sun shines as a faint point, 600 times dimmer than on Earth. And yet that weak light paints color onto the haze, scattering into electric blue. Every particle in that glow has lived through radiation frost, sublimation, and reformation. They are the ghosts of an atmosphere that keeps rebuilding itself. When NASA released the image, people called it a goodbye portrait. But maybe it's more than that. Maybe it's a reminder that endings can look like beginnings when viewed from far enough away. Look closer. The edge of the planet is lined with brightness. That rim isn't reflection. It's refraction sunlight bending through the air one last time before vanishing into night. The moment you realize what you're seeing, it hits you, you're looking at sunset on Pluto. Have you ever thought about what sunset means when the sun is just a star? As the probe continued to move away, it passed through Pluto's shadow. For a few minutes, the sun disappeared completely, and the only light came from Pluto's faint atmospheric glow. Instruments recorded how that light dimmed and flickered, allowing scientists to measure the exact thickness of the haze. From that data, they concluded the atmosphere extends nearly 1,500 kilometers above the surface, 10 times higher than expected for such a small world. That's the paradox of Pluto, small but vast in spirit. When sunlight returned, the probe turned its cameras one last time. Behind it, Charon trailed faintly in darkness, a gray companion following the same orbit, now fading into the endless. Together, they looked like two souls drifting apart across eternity. You can almost hear the silence. If you imagine yourself aboard New Horizons looking back through the window, what would you feel? Pride, sadness, or that strange ache that comes when you realize you've seen something no one else ever will again, because no one will, not for generations. NASA says there are no plans for another mission to Pluto in this century. By the time we return, the planet's atmosphere might have collapsed, completely frozen, back onto the surface as the planet moves farther from the sun. That beautiful blue haze we saw might already be gone. It's strange, isn't it, that the moment we finally saw Pluto in full color might also be the last time anyone does for hundreds of years. But maybe that's what makes it so human. The fact that we reached out into the cold and for a brief instant made contact. After leaving Pluto, New Horizons set its course deeper into the Kuiper Belt, the vast frontier of icy bodies that circle our solar system like ancient debris. It flew past another world in 2019, Arakoth, a reddish contact binary that looks like two snowballs stuck together. The images were breathtaking but quieter. The world seemed untouched, as if it had never been visited by light before. That's where New Horizons still is today, billions of kilometers from home, sailing through the dark. Its signal grows weaker every year, yet it continues to send whispers of data, the dust density of the Kuiper Belt, the faint glow of interstellar radiation, the temperature of space itself. It's become a ghost ship, but a faithful one. The spacecraft's plutonium power source will run out by the mid-2030s, after which it will go silent, another artifact drifting through eternity. But even then, it will keep traveling, leaving the sun's gravity, crossing the heliopause, and joining Voyager 1 and 2 in interstellar space. It will carry with it a tiny memory of Pluto-frozen photons stored in silicon, telling the story of the farthest world we've ever touched. Pluto itself will go on, orbiting slowly around the sun. 1 year, there lasts 248 Earth years. By the time it completes a single orbit, since our discovery of it in 1930, humanity will be long changed. And yet somewhere out there, the light we sent and the light we received will still be traveling. That's the quiet miracle of exploration. Even when the mission ends, its light keeps moving forward. Do you ever think about that? That every photograph you've ever seen of Pluto is actually a message from the past light that left the planet long before you were born, arriving just now carrying its story across space? If you close your eyes, you can almost feel it, a thin blue glow in the dark, a small world refusing to disappear. There's a phrase NASA engineers often use: the pale blue goodbye. It's what they call Pluto's farewell image, the one where the haze shines brightest against black space. They say that when the photo arrived, the mission control room went silent. No applause, no cheering, just quiet, because everyone knew they were witnessing something that would not happen again. It wasn't just a photograph. It was a revelation that even on the edge of darkness, beauty persists. And maybe that's what Pluto wanted to show us all along, that distance doesn't diminish wonder, it amplifies it, because wonder grows in silence. Even now, when you look up at the night sky, Pluto is there, faint, invisible to your eyes, but steady. It's still reflecting sunlight, still turning, still breathing. And if you could see it through that blue haze again, maybe you'd realize that what New Horizons really found wasn't just a planet. It found a mirror, a reminder that even the most forgotten places in the universe still have stories worth hearing. And maybe in that reflection you see yourself, still moving, still glowing, still reaching for light even at the edge of darkness. It begins with silence, not the kind that feels empty, but the kind that listens. When New Horizons sent its final data home, the last wave of signals crossed 5 billion kilometers of space. Each bit of light took more than 4 hours to reach us, traveling at the speed of truth. When it arrived, the engineers at Mission Control didn't cheer. They just stood there watching a screen that glowed with numbers, quiet, glowing proof that something human had touched the edge of darkness and returned. And in that quiet moment, something shifted, because for the first time we weren't just looking outward, we were looking back. If you think about it, that's what space exploration really is, a mirror. Every world we visit reflects something about ourselves. Mars shows us our curiosity, Jupiter our chaos, Saturn our elegance, and Pluto shows us our endurance. You followed it now through red scars and blue haze, through mountains of ice and seas that breathe in centuries. You've watched a world stripped of its title still shine brighter than it ever did as a planet. So let me ask you, what does it mean for something to be small if it can still inspire awe? What does it mean to be distant if your light can still reach someone's eyes? When Clyde Tombaugh discovered Pluto in 1930, he was 24 years old, peering through a telescope in Arizona. He died before New Horizons launched. But NASA placed a small vial of his ashes aboard the spacecraft, so when the probe flew past Pluto in 2015, the man who discovered it finally came home. There's something profoundly human about that, isn't there? The idea that our curiosity can outlive our bodies, that even dust can travel farther than dreams. Clyde once wrote, "It's still out there waiting for us," and he was right. As New Horizons moved beyond Pluto, it turned its camera back toward the sun. From that far distance, the sun was just a single bright pixel, and all the planets Earth, Mars, Jupiter were invisible in the glare. That's when it hit the team. This was what home looks like from the edge. Not a world, not even a dot, just a shimmer in the dark. And somewhere inside that shimmer you are sitting right now, breathing, listening, existing. Do you ever think about that? That you are part of a planet so small it can vanish inside one pixel, yet so full of life that it can build a machine to see that far. That's the contradiction of being human fragile but infinite in intention. When NASA released the final map of Pluto, every crater, every ridge, every plane, it wasn't just a chart. It was a love letter to a world we almost forgot, to a frontier we reached with light, patience, and mathematics, to the idea that mystery is not an obstacle but an invitation. Pluto reminded us that planet is just a word, but wonder is eternal. Back on Earth, you can still find people who remember the day the images arrived. The blue haze, the heart-shaped plane, the crimson scars. It was as if the universe had been saving its most poetic world for last. Children pointed at the screens. Adults cried quietly. For one brief moment, humanity shared the same thought. We are small, but look how far small can go. Years later, New Horizons continues to send faint signals from the Kuiper Belt. It's exploring a region we once thought was just debris, but now we know it's the cradle of the solar system, a museum of beginnings. Everything out there is ancient, untouched, unchanged, since the birth of the sun. Pluto is just one piece of that puzzle, the largest shard of a forgotten time. And as the spacecraft drifts onward, it carries more than data. It carries our handwriting in binary code. It carries our questions. It carries our quiet. Sometimes when the data stream pauses, the engineers imagine the probe floating there, surrounded by stars, its tiny antenna still whispering home. They know one day it will go silent. Its power will fade. Its circuits will freeze. But even then it will keep traveling, through the heliopause, into the interstellar dark, becoming one with the same emptiness it once dared to cross. And maybe millions of years from now, another civilization will find it a small object adrift, carrying the story of a species that once looked up and said, "Let's go see." So, what have we learned really? That warmth can hide beneath ice, that distance can glow, that even forgotten worlds can sing when touched by sunlight. But maybe the real lesson of Pluto is simpler, that wonder doesn't depend on size or fame or titles. It depends on attention. You can lose everything, your name, your place, your orbit, and still be radiant if someone remembers to look your way. That's what you and Pluto share. You are both small, both fragile, both luminous. If you were to go outside tonight, find the darkest corner of the sky and point your gaze toward the constellation Sagittarius, you'd be looking roughly in Pluto's direction. You won't see it. It's far too faint. But it's there, orbiting, slowly carrying the sunlight we left behind. And maybe that's enough. Because the story of Pluto isn't about discovery or demotion. It's about endurance, about what happens when light meets patience. And when you think about it, that's what we all are, light wrapped in patience. Someday, long after New Horizons stops talking, Pluto will still circle the sun. And on some future Earth, another young astronomer will look up from another telescope, chasing another unknown. And they'll find something faint moving across the stars, and they'll whisper the same word we've been saying for a century there, and the story will begin again. You see, in the end, Pluto wasn't waiting for us to name it. It was waiting for us to understand it. And in understanding it, we remembered something about ourselves. That exploration isn't about finding something new. It's about rediscovering the light that was always there, waiting to be seen again. So now, as our journey ends, close your eyes. Picture that little world glowing blue at the edge of black space. Imagine the probe still drifting, still carrying the whispers of Earth. And then ask yourself, what if the universe isn't expanding outward, but inward, pulling all that light, all that memory back to where it began? If so, then Pluto isn't far away. It's right here in your imagination, in your wonder, in the quiet corner of your mind where light never truly fades.